Hello there, students. We're back to kinematics problems. So remember, these were problems involving displacement, velocity, and acceleration. Before we looked at them in terms of derivatives, that velocity is the derivative of the displacement function and acceleration is the derivative of velocity. But now we're going to look at going the other way. So if I have the velocity function, I can integrate that to get a possible displacement function. So displacement function, I could also think of as position function. So position tells me where I'm at relative to a starting point. If I calculate a definite integral between two locations, then I'm thinking about the total displacement. So displacement is how far away I end up going from some starting position to another. So that could mean, so my displacement between A and B, well, if I end up with my B position being behind my A position, my displacement could be negative. So I'm a negative distance. It's not really distance, of course, because distance would be positive, but my displacement could be negative 0 if B ended up at the same place as A, or positive if B ends up to the right or above A. So displacement can be any value. So positive, negative, 0. If I want total distance, that means that I'm thinking about how far I went overall. So if I started at point A and went this way and then back this way and ended up at B, my total distance would be, let's say, x plus y, or we could call it x1 plus x2. So in this case, I would find my total distance by adding those two distances together. I can also do that by integrating the absolute value of my velocity between A and B. So total distance is going to be what it says, total distance. We're going to add up all the different distances. Displacement, we're just going to integrate and find our values. Okay? So let's come look at this. So we've got velocity of a particle given by this function. Displacement, I'm just going to integrate from 3 to 5, 2t plus 5 dt. So I'll get a half of 2t squared, so t squared plus 5t, evaluated from 3 to 5. My velocity function from 3 to 5 is always going to be positive. So in this case, my displacement and total distance will be the same. I'm going to end up with 5 squared plus 5 times 5 is 50, minus 3 squared is 9, 5 times 3 is 15, 9 and 15 are 24. So we're going to get 26 meters because my original was meters per second. All right, my initial position, so this is telling me that S of 0 is equal to 3. So find the position at 4 seconds. I'm going to integrate my v of t. Of course, that was t squared plus 5t. Now I'm going to add this c. I'm going to plug in my initial value. So I know S of 0 is going to be equal to c, which is 3. So that now means that S of 4 will be 4 squared plus 5 times 4 plus 3, 20, 36, 39 meters. So I'm 39 meters away from some sort of starting or initial marker, because my initial position was 3 units in the positive direction. After 4 seconds, I'm 39 units in the positive direction.